Hey everybody, here we go. Lesson 2.1. We are now in chapter 2, and we are exploring this question, this chapter question down here. Why do temperatures on Earth increase when the amount of carbon dioxide or methane in the Earth system increases? Hey, go check out my chapter 1 review video, my overview video, to just quickly recap all the things, the major things we were supposed to have learned in chapter 1. I'm not going to do that right here. Our investigation question today: how can the amount of energy absorbed by Earth's surface change? So we did learn about carbon dioxide and methane, and that they are increasing carbon dioxide, increasing methane is going to increase Earth's temperatures as well. But why? Why does that happen? So today, how can the amount of energy absorbed by the Earth's surface change? Hey, here's all our vocabulary words right there. Here's our key concepts on the next slide. Number one, a system can be stable even as something flows into and out of the system. If this unbalanced flow is disrupted, there may be changes to the system. So as long as it's the same going in, the same coming out, we have stability. The next one, a change to either the amount of energy entering or exiting the Earth's system affects how much energy is absorbed by the surface. We're going to do a little game. It's not really a game. We're going to make some predictions. We're going to use the sim. We're going to do a couple things in order to explore that. Next key concept, temperature increases if more energy enters than exits. And the last one, temperature decreases if less energy enters than exits. Let's go to the lesson right here, 2.1. Hey, I'm going to read our introduction. I'm going to start with the chapter introduction. Energy entering and leaving Earth's system. You know now that there's a connection between certain gases in the atmosphere and increased global temperature. What were those? Oh yeah, carbon dioxide and methane. But why? Why? Your next challenge will be to discover exactly how these gases can affect energy in the Earth's system. Well, I want to know why. Okay, so what? They increase the temperature, but why do they increase the temperature? Let's read our introduction for today's lesson, 2.1. Introduction to Energy Entering and Leaving. The research you conducted as a student climatologist has shown that at the same time ice is melting on Earth, carbon dioxide and methane are increasing in the atmosphere, and that results in higher temperatures. But again, why? Temperature is tied to the amount of energy absorbed by Earth's surface. What can affect absorbed energy? Hey, check this out. Your warm-up, let's go ahead and take a look at that. It's a bucket. Here we go. Ooh, here we go. Imagine that you are filling a bucket with water, but the bucket has a hole in it. Why would you be doing that? Well, I don't know, because you're trying to learn about energy. What will happen to the level of water in the bucket? Okay, so we're pouring water in. There's a hole. The water's coming out. There's the level of our bucket. What's going to happen? Is the level of water going to increase? Is it going to decrease? Is it going to stay the same? Do you want more information? I'm going to give you a minute to answer that, so go ahead and hit pause. Some of you may have said, well, if there's a hole in it, all the water is going to just come out and the level's going to go down. Some of you said, well, maybe it depends on how big the hole is. I mean, if it's a tiny hole, the water level might still go up. You might be pouring water in faster than it's coming out. I don't know. But we're going to keep exploring this as we go through this lesson. Hey, the first thing is something that you really need to have the materials for. So I included them for you. We're going to play this. Oh, it's not a game. It's a model. It's a model. And here's what we're supposed to do. You should have something like this. This is what you all would have in your workbook if you had your workbooks. Now, I attached this to the lesson. You could print it out if you want. You could just draw this on a piece of paper. That's fine. But also what you're going to need are little energy cards, or tokens as they're referred to. Now, again, I attached these to the lesson. You could print these out if you want, or you could use something else, but you're going to need 20 of whatever it is. So, hey, coins would work great, or if you want to just cut out 20 little pieces of paper, that works too. Here's what you're going to do. Read the directions. Let's start right here. For every test, start with 10 energy tokens at Earth's surface and 10 in outer space. So what I'm going to do is I'm going to take, wrong page, 10 of these bad boys. I'm going to put them 10 in space, outer space, and it even says start with 10 tokens here. And I'm going to put 10 down on Earth's surface. Again, it says start with 10 tokens there. So that's how I'm going to start. 10 here and 10 down there for a total of 20. So smart. For some tests, you need to decide how much energy enters or exits. That doesn't change the amount that we're starting with, but sometimes it will give you some options. So let's talk about this. Energy enters. Here's how we run this. When you see that, you are bringing tokens from outer space down to Earth's through the atmosphere down to Earth's surface. If energy exits, when you see that, you're taking those tokens from Earth's surface through the atmosphere back in outer space. Okay, repeat 3 times and then record the final amount of energy at Earth's surface. Hey, let's look at this first one together. So it's test number 1. We're on a test where the same amount of energy enters and exits. Okay, energy entering 3. So I got to set up all my tokens. And here, let me see if I can actually show you what's going on. All right, so here we go. So the first thing it says is energy entering is 3. So what I'm going to do is I'm going to take 3 of my energies. I'm going to bring them through the atmosphere. I'm going to put them down on Earth's surface. And then what does the next thing say? Energy exiting is 3. Okay, so I take 3 of my energies through the atmosphere, back in outer space. Ooh, but what was that thing I was supposed to do? I was supposed to do that 3 times total. So I'll go 1, 2, 3, and 1, 2, 3. That's my second time. Third time, 1, 2, 3, and 1, 2, 3. Great. So now I need to analyze. Okay, so what is my final energy at Earth's surface? Well, I already counted all these up, people. I got 10 energies right here. Okay, so I'm going to write 10 right there. Great. What happened to the energy in test 1? Well, it gives us some options. The energy did what? It stayed the same. We should have the same amount of energy in outer space as we do down here on Earth's surface. So that's what we'll say. Energy stayed the same. Man, it was hard to hold my computer like that. So now do the same thing, but with these other scenarios. So energy entering, ooh, check this out. You get to choose how much energy is entering. A number greater than 3, but fewer than 7, okay? And remember, you're going to do this 3 times. So you might bring 7 energy tokens down, and then how many energy tokens would go back up? Oh, looks like 3. Make sure you count up the final energy at Earth's surface, and make sure you write down what happened here. Choose the select one. Did energy increase, decrease, or stay the same? And do that with all 3 of those tests. Go ahead and do that now. Pause. Next thing we get to do is watch a video. We love videos. Okay, so I uploaded this video to your lesson. Go ahead and watch it there and see if you can make a connection between what you just did with this energy model and this video. So go ahead and take a minute, watch that. Pause. So if you're like me, you're wondering, why did the water entering look clear and exiting look clear, but the water inside looked orange? How did they do that magic? I don't know. But hopefully it makes sense, and it's just kind of, like, oh yeah, okay, you open up the top valve more water's going in than coming out. You open up the bottom valve, or close off the bottom valve, and again, that increases the energy in the system too. So what we're trying to do is we're trying to make connections to what is happening in Earth's system to our energy model that we just did, this video, where energy is entering, energy is exiting, but sometimes at different rates. So let's go ahead and move on to the next activity, which is the sim. The first thing you're going to do is you're going to make predictions. Do not just jump into the sim and do all these things first. I want you to read through these and predict what's going to happen. Hey, let's take a look at this one. Test number 1, no change. So you open up the simulation. If you make no changes, what's going to happen to the temperature? Well, I think it's going to increase. Why would you think that? No. I think it's going to stay the same. If I don't change anything, I think the temperature is probably going to change the same. What about the amount of energy entering and exiting the system? Well, I don't know. Will more energy enter than exit? Less energy be equal? Go through. We have 3 tests that you're going to be doing. Predict what's going to happen with each of those tests. And then click on the second part of this activity. And it tells you exactly what to do here. Run the sim until the timer reaches 20 before pausing to make a change. Make only 1 change per test. Test number 1, don't change anything. Test number 2, you're going to increase carbon dioxide or methane, gas of your choice, to 500. And test number 3, you are only increasing the sunlight. So make sure you reset the sim every single time. Let it run for 20, make the change for test 2 and 3, and then when it reaches 40, observe the temperature, the energy entered, and the energy exited, and then record all of your results down here. Lastly, well, go ahead. Oh, I'm sorry. Go ahead and do that right now. Pause. Hey, really quick, let's talk about what we should have noticed. Why not? Let's do it right now. When you made no change in the sim, what you should have noticed was temperatures, they stayed basically the same. And that's because, C, right down here, the amount of energy that entered and exited was equal. You have the same amount of energy coming in as energy going out. What about carbon dioxide or methane? Well, hey, I chose methane. It's going to be the same for carbon dioxide. When you increase methane or carbon dioxide, temperature also increases. Why is that? What happened to the amount of energy? More energy entered than exited Earth's system in this situation. And then the last one for sunlight, when you increase sunlight, temperatures also increased. And same thing, more energy is entering Earth's system than is exiting Earth's system. So for the last thing, let's click on number 4. It's an application question about what we may have learned. Between the years 1200 and 1600, global average temperature decreased. Okay, so temperatures got colder. Which do you think is true about the energy that entered and exited the Earth system during that time? Hey, these look like the same exact options that we had with the sim. So if temperatures are decreasing, what do you think is happening with the amount of energy that is entering and exiting Earth's system? Explain your... I want to explain. All right, fine. I'll explain my answer. Do that. And hey, we will see you guys all tomorrow.